Welcome back, GVA students. Continuing on with Lesson 10. Today is Session 3, which is page 193 to 198 in your Ready textbooks. And we're going to go through every little bitty bit of it together. So, first of all, let's warm up our brains. As normal, we got 4 boxes, 4 letters, and we have 4 expressions. These are our expressions for today. 15.2 minus 9.2 in box A. 15.4 minus a negative 9.4 in box B. 9.3 minus 15.3 in box C. And negative 9.5 minus 15.5 in box D. So we're doing some same and different today. What are the same about these 4 expressions and what's different about them? Get a pencil and paper, take a few minutes, work out as many differences and similarities as you can think of, and we'll be back and talk about them. Hey guys, welcome back. So, what'd you find? The obvious is that they're all subtraction expressions, right? Now, these subtraction expressions differ a little. A is a positive difference between 2 positive numbers. A and B both have positive values, if you solve those. C is a negative difference of positive numbers. And C and D have negative values. And did you notice that D has the least result as well? So there are other similarities and differences, but if you spotted those, good job. So let us move on to our first page, page 193. As you see, we are developing, adding, and subtracting positive and negative fractions and decimals. So, more work with rational numbers today. Let's look at our sample problem. May releases a lantern for the Lantern Festival. You've probably seen lantern festivals before, right? That's you've seen them in they're in anime and they're in some cartoons, and you may have seen them in real life. You have a little paper lantern and you put a candle in it, and when you light the candle, it makes the lantern float, just like a hot air balloon, and it goes way up and up and up until the candle burns out, ostensibly, at which time it flutters gently back to Earth, hopefully not catching any forests ablaze. But in this case, it doesn't, because Mai stands in a field that is 0.5 meters below sea level. The lantern rises 913.9 meters. That's way up there. Then the candle in the lantern goes out, and the lantern comes down 925.2 meters to land on the surface of a lake. What is the elevation of that lake relative to sea level? How would we figure that out? Give it a shot. Try it out. Use all the tools in your toolbox. And when you get an idea, we'll come back and talk about it. All right, welcome back. What did you find? A couple different ways you could solve this, right? Let's take a look at one way that you could do it, and that's with a number line. So here we have our friend May. Here she is at 0.5 meters below sea level. The green line's the sea level there, right? She lights her lantern, and it floats up 913.9 meters. And it hangs up there for a while till it burns out, and then it falls 925.2 to land on the surface of this lake. So, what's the elevation of the lake? Well, to find out, one thing we can do is we can find out what this top elevation is, right? How high does it get altogether? It raises 913.9 meters, but remember, we're not starting from 0, we're starting at 0.5 below 0. So what we can do is we can figure that out by saying 913.9, which is how far it goes up, minus 0.5, which is how far below ground level we started, and we get 913.4 meters elevation, right? So in other words, you're finding the whole distance minus the part that's below sea level. So that gives you the distance above sea level, 913.4 is where we end up, right? Because 913.9 minus that half a meter leaves you at 913.4. So that's where we are. The paper lantern starts going down. So this paper lantern falls 925.2 meters. So how far below sea level is it when it finally lands? Well, to do that, we just have to subtract, right? We find the difference between 913.4 and negative 925.2. And if we do that, that looks like this, right? We have negative 925.2, which is how far we go down. 913.4, which is where we started with. And if you subtract 925.2 and 913.4, what we're left with is negative 11.8, right? 11.8 meters below sea level. And that's what we end up with. So if you work it out this way, just go step by step, right? Where you start with, how far we go. That tells you how high you are. Then from how high you are, how far you've fallen, and then where your ending point is. So one way we found that out was graphically with that number line. The other way we can do it is mathematically, right? And to do that, it looks like this. So the first thing we have to do is find the change in elevation that the lantern gave us, right? We know that it went up 913.9 meters altogether, and we know that it went down 925.2 meters. So altogether, its change was negative 11.3 meters. And that's not its final resting place because we didn't start at sea level. So to find the ending point, we have to take that point that we started with and then add the change to it. So the ending point was negative 0.5 below sea level. The change was negative 11.3 below sea level. And so our ending point, just add negative 5 to negative 11.3, right? We're adding two negatives, so we're adding together. And we get negative 11.8 meters below sea level. And that's two ways we could have figured that out. If you got one of these two methods, good on you. If you got 11.8 meters below sea level, even better. So let's move on to the next page and see what we have here. Okay, now if we look at this next page here, it talks about a picture, drawing a diagram to model the lantern's movement. Hey, this looks a lot like what we came up with, right? We started off 0.5 below, we moved 913.9 up, we got 913.4 as the height. We then took 925.2 down, and we end up at the level of the lake, which is negative 11.8. Pretty good. Now, look at this. You can add and subtract from left to right, right? Which is kind of the way we started with. We started off with negative 0.5. We added 913.9. And we subtracted 925.2, right? That's kind of going along with what was happening in real time, right? It started there, it went up this far, and then it went down again, and that's what we're finding out in order. As it works, as it happens. Now the other way we could do this is you can reorder the terms, right? Now you don't have to do stuff in that order. You can do whatever it takes to make it easiest to manipulate those numbers. And if you're adding, you can add things in any order you want to. We've started off with 0.5 and 91.3, 913.9 and negative 925.2. Now look what we've done. We've taken this and we've made it an addition and subtraction problem and made it all addition problems, right? Nothing wrong there. We just take minus positive 925.2, make it plus a negative 925.2. And now we can switch everything around because everything's being added together. So what have we done? We've taken 0.5 and negative 925.2, put those together. And then we're doing 913.9 is being added separately at the end. So we're adding these negatives first. So we add negative 0.5 and negative 925.2, which gives us negative 925.7. And then we add 913.9, which means we're subtracting those two numbers, and that gets us negative 11.8. So this reordering thing looks interesting. Let's talk some more about that. What do you say? Let's move on to page 195. And I have an idea that this will probably answer that question about ordering terms around. Look at the picture it. That's the diagram that we drew at first, right? Does the lantern end up lower or higher than its starting point? And how do the arrows show the lantern's movement? Well, if you think about it, it started off at 0.5 below sea level and ended up at negative 11.8, so it ended up lower than it started, right? And how do the arrows show the lantern's movement? Well, it's kind of obvious. The arrow up, the lantern rises, arrow down, the lantern falls. It's just showing the path of the lantern, up or down, and it moves along the number line, either up or down, which means it's moving either in a positive or a negative direction, and that's why we use positive or negative numbers to illustrate whether it's rising or falling. So, question 2, look at the first model it. All right, that's, again, the number line we saw. What is the value of the expression negative 0.5 plus 913.9 minus 925.2? What is the value of the expression negative 5 plus 913.9 minus 925.2? Negative 11.8. So how does that expression show the movement of the lantern? Well, we know that too. The addition shows the lantern rising, and a subtraction shows the lantern falling. So when you're looking at it and you're adding a positive number, or you're subtracting a positive number, or for that matter, if you're adding a negative number, that means the lantern's moving in the downward direction or towards 0 on the number line. So looking at that second model, why did we change the order of the terms like that? What's the point? Why on earth is that a thing? You can change the order of the terms because of the commutative property of addition, right? That just means changing the order of the add-ins doesn't change what the sum is. In other words, as long as you're adding things together, you can add things in any order, right? 1 plus 5 plus 3 plus 2 is the same as 5 plus 1 plus 3 plus 2, which is the same as 5 plus 2 plus 3 plus 1. It's all the same thing. You get the same answer. You're just adding things in a different order. These are more complicated numbers, but it's the same idea. So how does changing the order of the terms change the way you find the sum? In other words, why on earth would we want to use the commutative property of addition? Anyway, why not just do it from the beginning and work yourself all the way to the end? Why is it a big deal? It's all about making things easier, right? Math is all about finding the easiest way to solve something, using all the shortcuts and all the little tricks that we know to get an answer without going the long way around. So, think of that. If you combine all of the positive and the negative numbers first, in other words, do the addition first, then you only need to find a subtraction once. If you add everything together you can add together, then you have one subtraction at the end. And that's easier, right? Because you don't want to do like an addition and a subtraction and an addition and a subtraction. This way, you're just doing the easy stuff first. And nothing wrong with that. So consider the expression. I love it when textbooks say that. Consider the expression. Consider the expression 1 5/6 minus 2 1/3 minus 1 1/6. To find the value, which two terms might you combine first, and why? What do you think? There's a couple different ways to do this, and there's not one right way, right? Many paths through the forest. As long as it gets you to where you want to go, do whatever's easiest for you. Well, the first thing that I would do is make everything an addition problem, right? Because right now we're subtracting. And if you're subtracting, you can't just switch terms around, right? Because 5 minus 3 is a lot different than 3 minus 5, right? But if we have 5 plus a negative 3, then negative 3 plus 5 gives you the same answer. So as long as you're adding and keeping the terms with the numbers, then you can do whatever you want with them as far as adding goes. In other words, if we turn it into this, if we say it's 1 5/6 plus a negative 2 1/3, plus a negative 1 1/6. Now we can swap all those numbers around and add them any direction we want to. First thing I would do is make them improper fractions, just to keep everything, as simple as possible. So, notice I took 1 5/6. 6 times 1 is 6, plus 5 is 11, so it's 11/6 for this one. Negative 2 1/3, 3 times 2 is 6, plus 1 is 7, so that's negative 7/3 for this one. And negative 1 1/6, 6 times 1 is 6, plus 1 is 7, so that's negative 7/6 for this. So now we have 3 terms that we're adding together. 2 of them are negative, 1 of them is positive. So what can we combine first? Well, think about this one. You could add it like this. You could say that 11/6 plus negative 7/6, and then add the negative 7/3. In other words, keep the like denominators together. That way, you can add 11 and negative 7, and then once you do that, you can find the common denominator with the other one. But sometimes that'll save you some work because you're not having to find common denominators across a whole lot of different terms. So that's one option. Keep your denominators together. Now notice what I've done. I haven't changed anything, right? I have 11/6 here. I have negative 7/6. I took it from the end over to the middle. And I had negative 7/3 and put that over here at the end. And then I just put brackets around it so you can see that I'm doing this first. But ultimately what I'm doing isn't changing anything. You're still just adding these 3 things together. Another way we could do it, you could do it like this. You could put all your negatives together first. You can say, okay, well, we have negative 7/3 and negative 7/6. Now we'd have to get common denominators, but after we do that, we're just adding these 2 numbers together, right? Because it's a negative plus a negative. So we add them together, and then we take that sum and add 11/6. Now we're going to get a negative result from this because we're adding 2 negatives together, so we know the answer is going to be negative. So this is going to be a subtraction problem, taking this sum and then adding this. But we know that we're getting the addition out of the way first. So reflect on the models and the strategies you've used today. As usual, I will leave that for you. And let's look at our next page, 196. 196, use what you learned to solve these problems. A helicopter is 19.25 meters above the top of a canyon wall. It goes down 27.60 meters, passing into the canyon. Then it goes up 5.25 meters. What is the new position of the helicopter relative to the top of the canyon wall? So we start off at plus 19.25. We're going down 27.6. And then we're going back up 5.25. So we can solve that by just looking at the numbers and doing what it basically tells us to do. And as you can see, here's what it starts off with. We're starting off at 19.25 above, right? We go down 27.6 and then back up 5.25, right? That's just what the word problem told us. But let's move some stuff around to make it easier. Let's take that 525 down at the end and move it over next to our 1925. That way we have 2 positive numbers together. We can add those. So we'll add those first. And then we'll subtract out that 27.6. So we add 19.25 and 5.25. Add those together, you get 2450, or 24.5. Then we take 24.5, and then we have to add a negative 27.6. So that means we're subtracting, right? So you subtract 27.6 from 24.5. And since 27 has the largest absolute value of the 2, we know that the answer is going to be a negative. Because if we take 27.6 away from 24.5, then it's going to take 24.5 away. It'll still have further to go, so that pushes it into the negative land. That's why we use a negative as the answer. And the answer is negative 3.1. So the new position of the helicopter relative to the top of the canyon wall is 3.1 meters below the canyon wall. So it's ending a little bit lower than ground level. How about that? Let's look at number 8. And I'll let you try number 8. So let's look at it. The temperature during the day is 5.4 degrees centigrade, another cold day in Ready Land. After sunset, the temperature falls 7.5 degrees. Wind chill makes the temperature after sunset feel 6.3 degrees colder. What temperature does it feel like after sunset? And show your work. So, let's pull some data out together. All right. The temperature starts off at 5.4 degrees centigrade, and that's positive 5.4. It falls by 7.5 degrees, and the wind chill makes it feel even colder than that. So it looks like we're going to have a temperature, and then drop that temperature down, and then drop that temperature down again. So we're going to end up with something that's down in the negative range, aren't we? That's my estimation anyway. Let's see if it works. So you work this out and show me what you get, and we'll talk about it in just a second. Okay, welcome back. Here we go. So, see if you got something close to what I got. All right, what you start off with is 5.4 degrees. Then you go down 7.5 degrees, and then down again 6.3 degrees. Now, because these are all subtractions, I'm going to make this an addition problem. So we'll just add the opposite. So we got 5.4, that's the same. We add a negative 7.5, and then we add a negative 6.3. So we have a positive and two negatives together. I'm going to go ahead and add those two negatives together first, even though they're at the end. I don't care. I can add them in any order I want to, and I want to add the negatives first. So we take 7.5 and 6.3, add those two things together. You're left with a negative 13.8, because you're adding the two, right? You're adding 7.5 and 6.3. All right, then, now we can take that negative 13.8, we can add it into that 5.4. So now we got negative 13.8 plus 5.4. That means we're subtracting. And I worked my subtraction out on the side here. 13.8 minus 5.4, 8 minus 4 is 4, 13 minus 5 is 8. That gives you 8.4. Positive or negative? Well, the largest absolute value of the two is that 13, right? Because 13 is larger than 5 is. So our sign stays with the larger of the absolute value, so it's a negative. So we have a negative 8.4. So it feels like 8.4 degrees centigrade below zero, which is very, very cold. What do you think? You getting the hang of it? I think you are. All right, let's look at our next one. Here we have, what is negative 5.5 minus 9.25 plus 2 3/4? And show your work. This one's a little bit more involved. Think you can handle it? Try it, try it. See what you can do. Put me on pause, work it out, and when we come back, we'll talk about it. All right, you're back, you're back. How'd you do? How'd you do? Let's take a look. All right, here's what I got. So we started off rewriting the question down, right? Negative 5.5 minus 9.25 plus 2 3/4. Now I see that we have a subtraction in here. Let's make that an addition so we can move things around if we need to. And that gives us negative 5.5 plus a negative 9.25, because you're adding the opposite of 9 1/4. And we're just keeping 2 3/4 the way it is. So what do we have? Well, for one thing, we have a bunch of mixed numbers. So let's make those improper fractions. And let's make common denominators while we're at it too. Because you'll notice we have 2/4 and 1/2. So we can take that half and make that into a quarter while we're doing it. So we'll start from this side. So 2 3/4, 4 times 2 is 8, plus 3 is 11, 11/4. 9 times 4 is 36, plus 1 is 37, that's negative 37/4. And then 5 times 2 is 10, plus 1 is 11. So that's 11 over 2. Now, to get to 2 to 4 is multiplying by 2. So 2 times 2 is 4, and 11 times 2 is 22. That gives us negative 22 fourths. So we have 2 negatives and a positive, so we're going to take those 2 negatives first and add those together. So we have negative 22 fourths and negative 37 fourths. Now because there's 2 negatives, we're adding them together. That means we just add, right? And added this over here to the side. 22 plus 37, 7 and 2 is 9, 3 and 2 is 5, so it's 59. Now remember, we're working with negatives, so it's negative 59 over 4. And now we're adding 11 fourths. So if we have a negative and we're adding a positive, that means we have to find the difference between the two, so we're subtracting. Now you subtract 59 and 11, I did that over here. 9 minus 1 is 8, 5 minus 1 is 4. So it's going to be 48. Now out of 59 and 11, what's the largest absolute value? Well, 59 is. 59 is a negative number, so that's going to be a negative 48. And since we're dealing with fourths, then that's negative 48 over 4. So negative 48 over 4, I think we can make that back into a mixed number, or maybe even an integer. So we divide 4 into negative 48. I did it over here. 4 goes into 4 once. 4 times 1 is 4. Bring the 8 down. 4 times 8, or 4 goes into 8 twice. And 2 times 4 is 8. Nothing's left over. So 4 goes into 48 12 times. So negative 48 fourths is negative 12. So notice I did every step, right? I didn't make any shortcuts, but I made, one shortcut technically when I made this an improper fraction and I found a common denominator. But other than that, everything I spelled out is step by step, so you can see really clearly how I got from one step to the next. That's a good thing to do when you're working with problems like this, is don't shortcut yourself, right? Paper's cheap, so are pencils. Write it down. And computer pages are even cheaper. So that's the end of page 196. Let's move forward to page 197. The green pages. Ooh, it's up to you now. Let's see what we have. So, it's a hummingbird question. Hummingbirds. Beautiful little things. The smallest hummingbird is about the size of a bee. Tiny, tiny little creatures. Hummingbirds, the example says, sip 2.5 fluid ounces of the liquid in the feeder. Then 1.5 fluid ounces of food is added to the feeder. And last, hummingbirds sip another 3 1/4 fluid ounces of food. What is the overall change in the amount of food in the feeder? And you can write an expression to represent the situation as they have done. See, we start off with negative 2.5 because that's how much they drank, right? So it started off at some point, they drank 2.5, so it's going down 2.5. That's why it's a negative 2.5. Then you add more, that's plus 1.5. And then they drink 3 1/4 ounces more. So it's going down by 3 1/4. So then we reorder the terms. They have negative 2.5, 1.5, and negative 3 1/4. They brought that negative 3 1/4 over this way. So if 2.5 minus 3 1/4 plus 1 1/2. If it were me, what I would have done is I would have made that adding a negative, because that means when you're moving these around, you don't run into the trap of forgetting where one of your negatives is. So this way we're dealing with pluses all the way around. So if you're adding everything together, now you can swap around. You don't have to worry about losing a negative somewhere, because they will get lost if you're not careful. So what we've done is we've taken that 3 1/4 and moved it over here and moved that 1.5 back to there. So that gives us that. So we have 2 negatives and 1 positive. So what they're doing is they're adding negative 2.5 and negative 3 1/4, getting negative 5 3/4. Then they take 1.5, just bring that down. So then they're taking negative 5 3/4 plus 1.5, and that gets them negative 4 1/4 because you're subtracting here. So the overall change in the amount of food is 4 1/4 fluid ounces. Makes sense. Let's look at problem 1. The feeder in the example had 16 fluid ounces of food in it to start. So how much food does it have now? We're adding something to that, right? Well, not as difficult as you might think, because remember, we went through all this just to find out how much food is left over. So we know 4¼ ounces is left over. We also know we had 16 ounces to start off with. So that gives us the 2 bits of information we need to find out how much is left now. So use that information, find your answer, and come back when you're done. All right, hello, hello. See what we have. See if you did it much like this. Here's what I did. I said you had 16 to start off with, and we ended with negative 4¼ So then I had 16 minus 4¼ I changed that to an addition problem because it's easier. I always like to make subtraction problems into addition problems because it means you can swap things around easier. So I did that. I said minus 4¼ is plus a negative 4¼ Easy peasy. I left 16 as it was. I decomposed negative 4¼ I chunked it up into negative 4 and negative 1/4. And I added those two together. So now I got 3 terms. I got 16 and a negative 4 and a negative 1/4. Why'd I do that? Well, for one thing, I don't have to find improper fractions now. I can just work with the whole numbers and then work with the fraction, and I'm not dealing with all that messy improper fraction stuff. Because, see how this works out? If I add now 16 and negative 4, right? I got 16 plus negative 4, I'm doing first, and saving my plus a negative 1/4 till last. So 16 plus a negative 4 is 12, right? Because 16 minus 4 is 12. And then I just bring down that negative 1/4. Well, what is 12 plus negative 1/4? That's like 12 minus 1/4, right? If you got 12 and you take 1/4 away from it, you're left with 11 3/4. And that is the answer to that question. You have 11 3/4 fluid ounces now if you started at 16 fluid ounces and all that stuff happened to it. What you end up with is 11 3/4. Onward, page 198. Okay, this is a multiple problem, isn't it? It's many problems in one. Is each expression equivalent to negative 2.7 plus a negative 3.1? How are we supposed to know that? Well, use what you know about addition, subtraction, and the properties. So let's see. We have negative 2.7 minus a 3.1. Is that the same thing? Well, we know that subtracting a number is the same as adding its opposite. So is this what we have up here? Yeah, negative 2.7 plus a negative 3.1. That's the same thing as negative 2.7 minus 3.1. So we can call that a yes. What, you think I'm going to do them all for you? No, no, no. Put me on pause. Do the other 3 and then come back when you're ready. All right, hello, welcome back. Let's see how'd you do on the other 3? Let's see. We have negative 2.7 plus negative 3 plus negative 0.01. Aha, look at that. That's a decomposed number, isn't it? Negative 3 plus negative 0.01 is exactly the same as negative 3.1, just breaking it up into its parts, right? So, yeah, that's exactly the same. So, if you've been following along with the decomposing numbers, you'd find out what that is. Let's try number C. Negative 2 plus negative 0.7 plus negative 3 plus negative 0.1. What does that give you? Well, let's see. Negative 2 plus negative 0.7 is negative 2.7. That's what we have here. And negative 3 plus negative 0.1, well, that's negative 3.1. So all that's saying is that it's just blocking up this and that. It was decomposing those, right? So add those together, and yeah, we have negative 2.7 plus negative 3.1. So that's exactly the same as the other. So problem D. Negative 2 plus 0.7 plus negative 3.1. Is this another decomposed number? Well, let's take a look at it. Oh, wait a minute. We have negative 2 plus 0.7. Negative 2 plus 0.7 is a subtraction. So negative 2 plus 0.7 does not give you negative 2.7. So that would not be true at all. That is an incorrect statement. So we will mark that as a no. So how'd you do on that one? Did the last one trip you up a little bit? Yeah, it's all right. You just have to look pretty closely at what the problems are actually saying and keep track of those negatives and if you're adding or subtracting. Let's look at number 3 together. Reth is playing a game. First, he loses 4.8 points. Then he gains 2.5 points. Finally, he loses another 7.8 points. So what's the overall change in Reth's score? And of course, show your work. So that's saying that he loses 4.8. It's saying he gains 2.5. And then he loses another 7.8. So we have 2 changes in a negative direction and 1 change in a positive direction. So, try it out. Give it a shot. And come back when you're done. We'll see how you did. Okay, welcome back. There we go. What did you have? Does it look something like this? So we have negative 4.8. That's what we start off with, losing 4.8 points. Then we add 2.5 points. And then he loses 7.8 points, so we add a negative 7.8. Now, let's break these numbers up a little bit. We have a negative and a negative on both sides. Let's pull that negative over to the middle. That way we have 2 negatives together, so we can add that first. And then we have that 2.5 we're adding at the very end. So we have negative 4.8 and negative 7.8. That means we add those 2 things together. And I did the work over here on the side. 8.8 is 16, and 7 and 4 and 1 is 12. So I got negative 12.6. So negative 12.6, then we're adding 2.5. A negative and then a positive, we're adding together. That means we are subtracting. So if you subtract 12.6 and 2.5, 6 minus 5 is 1, 12 minus 2 is 10, and you're left with, because 12 is the larger number, right? Largest absolute value. 12 is greater than 2. So it's a negative 10.1. So the overall change in Reth's score was a drop of 10.1 points. Pretty good. All right. Let's take a look at this last one here. An autonomous underwater vehicle. Where does Ready come up with this stuff? An autonomous underwater vehicle is at an elevation of negative 8.25 feet. It dives down 6 2/3 feet to collect a specimen. I see a problem already. Then the AUV dives another 15 3/4 feet. What is the final elevation of the AUV? And show your work. I'll let you work this one out. I'm not going to give anything away beforehand. You do what you can, work it out as best you can, and we will talk about it when you come back, okay? Okay. Challenging, maybe? I don't know. Let's find out. Let's look at our work. Well, first of all, let's see what we have to deal with here. We start off with an elevation of negative 8.25, okay? So we're starting off below sea level because it's an underwater vehicle. That makes sense. It dives down another 6 2/3 feet, and then it dives again 15 3/4 feet. So it's going down and down and down and down. So that tells us that we're going to add all these things together, right? Because we're adding a negative to a negative to a negative. So that's the good news. We're adding stuff. The bad news is we're dealing with decimals and fractions and all kinds of stuff that doesn't play well together, so we have to fix it. So let's fix it. We start off negative 8.25, check. We go down another 6 2/3 feet, check. We then go down again, negative 15 3/4 feet, check. So what let's do, first of all, We got to make everything either a decimal or everything into a fraction. Since we only have one decimal, let's make it into a fraction. 8.25. Well, as you know, 0.25 as a fraction is 1/4, right? Just think of a quarter, 25 cents as a fourth of a dollar. Right? So we can make that into -8 1/4. And then we have -6 2/3 and -15 3/4. Now, what else do you notice about this? Well, two of these things have a denominator of 4. One of them has a denominator of 3. Now, we could make everything into a common denominator of 12, but I want to add those common denominators of 4 together first, because it's easier. If you're dealing with 4s or dealing with 12s, I'd rather deal with 4s. So we'll take that -15 3/4 and move it over next to the first one. That gives us 18 1/4 and 15 3/4, right? Both with negative. So a negative plus a negative, and we're just adding. So what is 8 1/4 and 15 3/4? Well, I've worked this off to the side. I did a little bit of decomposition here. I got 15 plus 8, right? 8 plus 5 is 13, and 1 plus 1 is 2, so that's 23 for the whole number. And 3/4 plus 1/4 is 1. So that gives us 23 plus 1, or 24. And since we're dealing with all negatives, it's a -24. So, lucky us. We don't have to deal with finding the other common denominator, because now we have a whole number. So we have -24 and a -6 2/3. Now, if we were subtracting, we might want to find a common denominator with, improper fractions and stuff. But in this case, we can take, since these are both negatives, we're adding them together. We could say -24 and -6. Well, that's just -30. And that 2/3 hanging out on the side, bring it over too. So -30 and 2/3. So, what's the final elevation of the AUV? It is 30 and 2/3 feet below sea level. And that, dear students of ours, is what we have for session 3. Stay tuned tomorrow, more fun with session 4. So session 4, you notice it's ratcheting up a little bit. Every session gets a little bit harder. So prepare yourself. Session 4 is going to be a fun one. So until then, stay safe, keep thinking about math, and I'll see you next time.